This is Arna, and today I'm going to be doing some reasonably hard physics problems from the textbook Exploring Creation with Advanced Physics by Dr. J. Wiley. This textbook is very well done. It explains every concept very thoroughly, giving you all the necessary explanations and requires you to respond thoughtfully. I recommend this textbook for anyone looking to do advanced physics and anyone with any love of physics at all. Also, I recommend his other textbooks of chemistry and biology, both also very well done. I'm now going to do another complicated question from the advanced physics book. A ship firing its guns at velocity initial of 750 feet per second at another ship which has run out of ammunition. To avoid the guns, the other ship is trying to hide. It gets behind an 2,600 feet from the tip of the mountain. How far from the tip of the mountain must the hiding ship stray before the firing ship can hit it? The firing ship can fire its guns at any angle. Okay, so this is a problem where it's best always to draw a diagram. So you would start by drawing an island with a mountain. The mountain's height from the question says that's 2,000 feet. This is at 4 significant digits, so it's 2,000.0 feet. And the distance from this ship to the base of the mountain is in 600.0 feet. And this is where the one ship's gun is. And it is trying to fire at a ship that's distance of, let's put it as D for now. And it is unknown. We want to see how far must it go before it can be hit. So this question is a little bit tricky. So you want to use the equation for firing a parabola to see how long it will take to reach the mountain. So we know that delta x equals VOT plus half AT squared. We're trying to figure out the t. So we know what VO is, and we know that half AT squared, it is equal to 0 because there's no acceleration in the x dimension. So we know that delta x equals VOT, the time, therefore time equals delta x over VO. We know what delta x is. It's 2,600. That's good. And this is over VO. We would think we know VO at 750. But we don't. We need to know the x component of the angle for VO. The x component for the angle is a little bit tricky though, because we don't know the angle. So we know that VOX equals the cos of theta. But we don't know what cos of theta is, and it's times by 750. We can leave that. Most people don't like to leave an unknown in their equation, but sometimes you need to. So now we can solve for the y. So VOY is also going to equal the sine of theta times 750. We can work out, though, that t to reach the mountain is going to equal 2,600 divided by 750. cos of theta. 3.467 because we have 4 significant digits. That's the x. The y is going to be that, but we do have, and that's times the t we have, and we have a half a t squared. We know that a t squared, it's going to be in feet per second, so it's not 9.81 but 32.2. So we know that delta x equals sin theta times 750 t plus a half times t squared. We know what x is at 2000 because we're trying to get above the mountain. That's equal to sin theta times 750. We also know what t is. It's 3.467, and that's times 3.67 over cos theta. We also know what this is. This is 16.1, 3.467 squared, and that is equal to 12.02, 1 over cos theta. 16.1 times 12.02 equals 193.5. No, it's 194 because 16.1 is only 3 significant digits. So we have 2000 equals 750 times 3.467. It's in 2 significant digits, so it's 2600. Interesting. Times by minus by, because acceleration due to gravity is negative, 194. 1 over cos theta squared. The strange thing is now is how do we know what this is? But we can use our trigonometric identities, which are quite hard to remember, so I'll just give them. And that's equal to 2600, and 1 over cos is equal to sec. So we're going to say, oh no, this is sin over cos. Sorry, that's not sec then, that's tan, which is fine, that's even easier to work with. And this is 1 over 94, and 1 over cos is sec, so this is sec squared. And if you look, sec squared is 1 plus tan squared. That's a trigonometric identity. Therefore, we can say that 2000 equals 2600 tan minus by 194 tan minus by 194, and this is 10 squared. We want to use the quadratic formula here because it is in that form. So the quadratic formula says ax squared plus bx plus c equals 0. When you use that, it says that x equals negative b plus or minus by the square root of b squared minus 4ac. That's all over 2a. We're not using x here, we are using tan, and a being and b and c being the coefficients. So we have b at 2600. So we're going to say That's 2,600. And negative plus or minus by the square root of 2,600 squared, which equals 676 point times 10 to the x minus by 4 times 194 negative and negative times by negative 2,194. 2,194. This is the square root, and this is over 2a. 4 times 194 times 2,194 is going to be 1.70 times 10 to the 6. That's going to be, so we have negative 2,600 plus or minus by the square root of 6.7 times 10 to the 6 minus by 1.70 times 10 to the 6 all over negative 194 times 2 is 388. So this is all over negative 388. We will work out what 6.7 minus 1.7 is equal to 5 times 10 to the 6. Square root of 5 times 10 to the 6 is 2.24 times 10 to the 3. So that's negative 2,600 plus or minus by 2,240 over negative 388. This is what tan is equal to. So let's add them. So 2,600 plus 2,240 is 360. So 360 divided by negative 388 is negative 92. No, negative is equal to 0.928. And the other option is if we negative them, it's going to be 2,600 negative minus by 2,240 and so divided by 388. That's going to give me 12.47. We are going to then use what's the arctan, because tan is equal to that, so we want to figure out what angle is it. So the arctan of 0.928 is giving me 42.8. 42.9. 42.9 and 12.47. We take the arctan of that, and that is going to respond 85.4 degrees. So this is between 85.4 and 42 degrees. That's where the ship must fire to get over the mountain. Now we need to see which one is the furthest or the closest, so you can see how far the ship must go to be the closest, because one of them is going to go like this and one of them is going to go like this to get over. You want to see how far is this one away from the mountain. And I will quickly do that. The range formula being R, which is the range, equals VO squared times sin of 2 theta over G. So we have 750 squared times sin of 2 theta, which we are going to put in, let's take 85. 2 times 85.4. This is all divided by 32.2 is 2790. So I now did the second range, and the second range is a lot further. If you want to know what the second range is, it was 1.74 times 10 to the 4 feet, which is way further. So we want the 84 one. The 84 one is 2,790 feet, and that's the total distance, but we want the distance from the mountain. So we have to minus 2,600 from that. That gives me 190 feet. This is what the total question asks, and the ship must be closer than 190 feet in order for it to not be shot. So I hope you enjoyed my explanation of these questions. Please comment below if you thought I didn't explain anything well enough, or if there's another question you wanted answered, or you just had a different way of doing the question. Thanks for liking, commenting, and subscribing.